Okay, welcome back. Today we are going to work on adding and subtracting rational expressions. And there's two things we need to remember when we are adding and subtracting rational expressions. And it's very similar to when we are adding and subtracting regular fractions. So for instance, and I know this is too simple for you, but let's just take this as an example. If I want to add 1/2 to 1/3, the first thing I need to remember is that I can never ever multiply either of these fractions by anything other than 1. Now I can be clever in how I write the number 1, but I can't ever multiply them by anything other than 1. So I can multiply them by 3 over 3 or 2 over 2 or 876 divided by 876, but it has to be something that eventually reduces to 1. The other thing I need to remember is that I need to find a common denominator for my two denominators. Okay, obviously this one's simple. The common denominator is 6. So I'm going to multiply this first fraction by 3 over 3, and I'm going to multiply this second fraction by 2 over 2. Of course, that leads me to 3/6 plus 2/6. And then I simply add what's in the numerator and leave the denominator alone. So this becomes 3 plus 2 all over 6, and it equals 5/6. So it's pretty simple, right? We're going to do basically the same thing with our rational expressions. All right, let's take our first example here, and let's see if we can make this a little bit bigger and find a nice common denominator for each of these. Now the interesting thing here is that x minus 1 sure looks a lot like 1 minus x. So I can change that pretty quickly simply by multiplying this guy right here by -1 over -1. Then this becomes 2x minus 1. And when I multiply this -1 on the top here, I'm going to get a plus 2x plus 1. This has a denominator now of x minus 1, and this still has a denominator of x minus 1. So now, since they have the same denominator, I can combine them, and I get 2x minus 1 plus 2x plus 1 all over the denominator of x minus 1. Well, now the math is pretty simple. The -1 cancels with the +1, right? -1 plus 1 is 0. I'm left with 2x plus 2x, which gives me 4x, all over x divided by 1. Pretty easy, right? So just to sum up, I multiplied by 1, a kind of special one, -1 over -1. And I found a pretty simple common denominator because all I had to do was switch that over, and this negative sign became a positive sign. Okay, so let's try a little more difficult example now. All right, this one's going to be a little bit harder, and I'm going to want to start by making sure that both of my denominators are as simple as they can be, right? So I'm going to rewrite this a little bit, and I'm going to make this x minus y divided by, and I can factor x squared minus y squared, that's just a difference of squares, so divided by x minus y over x plus y, minus 2 over 2x plus 3y. Now hopefully you see pretty quickly there that for this first term I'm going to get something that cancels, right? This x minus y is going to cancel with this x minus y. And I'm going to end up with 1 over x plus y. Now I can do that because it's the same as having two constants, right? If I had a 4 on top and 4 on bottom, I would cancel those out to simplify that. Okay, so I can do that here as well, and I haven't changed anything. Okay, I haven't changed anything at all. So now I can have minus 2 over 2x plus 3y. All right, so now I have to find my common denominator. And my common denominator is going to be the combination of this and this, right? Just like in our simple fraction that we looked at before, I had 1/2 plus 1/3, and I ended up having to multiply those to get 6. Well, I'm going to do the same thing here. I'm going to have to multiply this x plus y by the 2 plus 3y to come up with a common denominator. So for this term, I'm going to multiply this side by 2, oh, wrong tool there, by 2x plus 3y, there should be an x right there, divided by 2x plus 3y. And on this side, I will multiply by x plus y over x plus y. And when I simplify a little bit, I'll get 2x plus 3y all over 2x plus 3y times x plus y minus 2 times x plus y all over 2x plus 3y times x plus y. So I'm going to distribute this negative sign here, distribute this 2, kind of keep simplifying, right? And I'll get 2x plus 3y minus 2x minus 2y, all divided by 2x plus 3y times x plus y. That's going to simplify. Move this up, get a little bit more room. This 2x is going to cancel with this 2x. 3y minus 2y is just going to end up with y. So I'm going to end up with y all over x plus y times 2x plus 3y. Right? In the order that I write these terms in the denominator doesn't matter. Okay? So again, pretty straightforward as long as you follow our 2 key rules that you can only multiply the terms by 1 and you need to find a common denominator. So let's go ahead and try a couple more problems here. All right, number 3 is pretty tough. We've got quite a bit of factoring to do before we get started. This term looks fine here, but I've got this cubic term here, and I know that's going to factor. So I'm going to rewrite this, and I'm going to put 1 over x minus 2y minus, and there's nothing I can do with the the numerator. So I'm going to leave that as x squared plus 4y squared. But in the denominator, since that's a difference of cubes, I'm going to put x minus 2y. And that's going to be multiplied by x squared plus 2xy plus y squared. And that's going to be 4y squared right there. Okay? So now I can see that my lowest common denominator is going to have this x minus 2y. It's also going to have this quadratic term thrown in there. So I'm going to have some simplifying to do. I don't have anything to do with this guy, right? He's already got our lowest common denominator in there. So it's like having, say, 1/2 minus 1/6. I don't have to do anything to the 1/6. I would just need to do something to the 1/2. Same thing here. I don't need to do anything to this second term, but I need to multiply and do something with this first term. So I'm going to go ahead and I'm going to move that, see if I can move that guy over a little bit. And I am going to multiply him by this second term, which is this large quadratic x squared plus 2xy plus 4y squared, divided by the same thing, x squared plus 2xy plus 4y squared. I realize that's hard to see, but you'll see it at the bottom when I bring it down. Okay? And I'm going to end up with x squared plus 2xy plus 4y squared all over, and I'm going to make it easier on myself. I'm just going to leave it written as it originally was, because I know that all of this, after I multiply it out, I end up with x cubed minus 8y cubed. So I'm going to write it there just to save myself some room and space, but I know I can go back and forth as needed. So I'm going to put x cubed minus 8y cubed. And that's all going to subtract minus x squared plus 4y squared all over, again, x cubed minus 8y cubed. Okay? Then I can combine the top, and I can see right away that this x squared is going to cancel out with this x squared. And remember, these are in parentheses, these guys right here. Okay? And I'm going to have the 4y squared is going to cancel out with this 4y squared. And I'm going to end up with just this 2xy all over what I have in my denominator, which is x cubed minus 8y cubed. Okay? So pretty simple. We're going to try another one now. All right, so of course we left the most difficult one for last. You're not too surprised. So we've got some pretty heavy looking denominators there. So we're going to start by factoring these, and we're going to come up with, let me make this a little zoom in so we can see it. We're going to come up with 3x plus 13, and when I factor that guy, I get x minus 5 times x plus 2. And for this second term, I get 16 all over x minus 5 times x plus 1. Yikes. So my lowest common denominator, and I'm just going to write it up here so I don't forget, is going to be this x minus 5, which I have in both. So I'm going to write x minus 5. Then it's going to be this x plus 2, which I only have in my first term, so x plus 2. And then finally it's going to be this x plus 1, which I only have in my second term, x plus 1. Okay, so that's my lowest common denominator. So when I look over at this first term, I know I'm going to have to multiply him by x plus 1 over x plus 1 in parentheses. And for this second term, I'm going to have to multiply him by x plus 2 over x plus 2. So now I've got quite a bit of multiplying and combining of like terms to take care of. But when I multiply x plus 1, right, this right here, by 3x plus 13, I'm going to get 3x squared plus 10x minus 13. And then when I multiply 16 over here by x plus 2, and it's really a negative 16 because it's a negative sign, I'm going to get minus 16x minus 32. And I've kind of taken some liberties and combining some steps, but I think you guys can follow along by now. And the denominator is going to be my lowest common denominator, x minus 5, x plus 2, x plus 1. So my numerator, obviously, I can simplify quite a bit, and I'm going to get to 3x squared minus 6x minus 45 all over, still x minus 5, x plus 2, x plus 1. Then I see I can factor out a 3, so I'm going to go this way to save some space. I'm going to factor this 3 out, and I'm going to get an x squared minus 2x minus 15 all over x minus 5, x plus 2, x plus 1. Then I'm going to give myself a little more room here. Okay, I'm going to go this way now. When I factor this numerator up here, I should get 3 times x minus 5 times x plus 3 all over x minus 5, x plus 2, x plus 1. And now I can go ahead and get rid of that guy, get rid of that guy. And I'm finally left with 3 times x plus 3 over x plus 2 times x minus 1. Alright, so that's it. I know it's kind of a longer video. If you had any problems following along with any of these, make sure to just kind of rewind, take a look at it again, make sure you understand how that worked. And I'll post a couple other videos from online resources for you to take a look at as well. Alright, thanks for watching, guys. We'll see you in class soon.